so there's the unit test that's failed. We'll double click on this line down here, and it takes us to the point that failed. So the only thing I'm interested in is, oh, there's the line that died. Okay, so notice it passed the first two asserts, so it looks like it's somehow managing to add up the total hours appropriately, maybe. And it's figured out there's 2 reports in there, so it's totaling those just fine. The thing that it isn't doing is calculating the average. So the average of those two should be the initial value, which was, let's just get this right, 10 plus another 20 to give you the 30 divided by 2 samples. Okay? So the average is failing. Well, if we go look at get average hours, haven't written it yet, so no surprise that it fails. Okay, so let's calculate the average. Average is however many samples we've got. What's the total? Just do it this way. I'll put the return 0 back there. Where's it coming from?
Course hours totals.
There's no there's no data at the top of this class, right?
Yeah, it should be in the class extending the abstract.
Yeah, so remember the trick here, because this extends something, you always have to say, oh, okay, it could be that the information that I'm looking for is in the class that was it extended from, and so there's where the data is for total hours spent and the count of the totals. Okay. How can you get at it? Well, if those said protected on them, then you could get at them directly, but since they don't, since they say private, we're going to have to use get total hours spent and get report count in order to retrieve them. Okay? So one of the other easy ways to figure out is to hit control space and let it tell you what sort of things you can do from there. So in this case, I'm going to say total is get total hours spent. I'm going to say int samples is get, where did it go, report count, and then the value that we want to return. And we'll send that thing back. Okay, let's calculate the average and send it back. Okay with that? Okay. I'm just going to put a breakpoint there since it's new code, and we'll just go take a look and see what values are coming out of this thing. We'll run with the debugger. And we'll see what it does for calculating the average. So here we are in the debugger. Crack open the this variable. Do a step over. The total value is 30. Another step over. Number of samples is 2. So that's right so far. So the average should be one more step over. 15.0. Looks okay? Okay, so returns the average, fine. Just out of interest sake, I know that we're not sort of supposed to do this, but I'm going to go into the unit test, and just out of interest sake, instead of 30, I'm going to put in 29 there. And I'm going to change this to say the result should be 29. and we'll run it again with the debugger, and we'll go look and we'll see what the values are. Oops, that wasn't with the debugger. One more time. Oops. Oh, it's running the wrong unit test. Sorry, let me double check here. Oh, yeah, look, it's no longer correct. That's what the problem is. I'm just gonna go back and make sure I've got my breakpoint there. Make sure I'm running the correct test. Oh, that's because I forgot to modify this. This is actually 19. There we go. Okay, so started out at 10, added another 19, we should get 29. So the average should be 29 divided by 2. It was stopping on a breakpoint early because I hadn't messed with the unit test correctly. Now we'll just go take a look at the values. Do a step over. There's total, there's samples, there's the 29, there's the divided by 2. Another step over, and we'll calculate the average. And there's the average. Anything wrong with the average?
It's not right.
What should it be? 14.5. Oops. The reason I put this in here was because we hadn't done anything with floating point numbers.
Did you float the
so far?
Samples first?
And so, yeah, one of the problems here is that now we'll go back and look at it, and we'll see what the issue is with floating point numbers. So with a floating point number, we said this is an integer, that's an integer, and so if you do division, it's total is an integer divided by samples, which is an integer, so you get integer division, which means nothing after the decimal point. Okay? Now there's a couple of ways that you can do this. One of the ways is that you can put this thing into a floating point number. Okay? And now, since you've got a floating point number, it'll maintain floating point across the highest precision it can across that entire calculation. So any single floating point number in the calculation is enough to force it to use floating point all the way through. Okay? So that's one way of doing it. The other way of doing it is you could leave this as an int, and you could force one of the numbers to be a float with a cast. It would also do the same sort of trick. Okay? Either way will work. This is saying, oh, I want you to treat samples as a floating point number, so now when it does the division's going to be a floating point number, and things will be okay. Okay? Either way works. We'll just double check that in the debugger. Do a step over, step over, step over, and go look at the average. And now the average is what we expect, 14.5. Okay? So working with floating point numbers, you have to be a little bit more careful than you would be with regular numbers. There's a few gotchas in the process. So that's the first one of them. Okay? So now we've got average to work. I should really go back and change that test, but I'm not going to. My recommendation is if you're ever going to play with unit tests, when you're not supposed to, what I would do is I would save a copy of the original someplace else and then just splat the copy back so that you always test against the original at some point rather than the changed version. Okay, so we've got that all hooked up to go. So now we can turn around and run the test again and see if we're any more successful at running the unit test. And now add hours works, but course by name and course by average don't work, largely because we haven't written them yet. Okay, so back to the next task at hand. We'll see what we can do for making the comparators. Okay, So the first one is a comparator that does courses by name, apparently. How are you going to write one of those? Remember what the code looks like? This is the point where you probably go steal an example. We'll see if I can remember it off the top of my head. Return new comparator object that works for, I guess I could just steal this line. It's going to be one of those things that comes back, since that's what it promises to return. Like that. Okay, so all I did was I plugged in that word as the thing that I was supposed to send back, called the constructor for it, and now the complaint is you haven't written the methods that you need to write. We'll get it to do the work for us of writing the methods. So a comparator has a compare function inside it that takes two things, two objects, A and B. I'll just change the names to make them a little slightly more reasonable. And it figures out how to compare them. So what do you want to get out of A, since this is by name? Go grab course name. And the trick here is to usually just put them back into variables. So string A name is that thing. Let's go get B's name. And then if you want to put them in order, what are you going to do to them? Call compare to. So this is A name, since it's a string, dot compare to B name. We'll at least get them coming out in, starting out in name order. Okay. While we're at it, I guess we might as well do the one for average hours, since it's there. So I'll play the same game with that one. I'll steal that thing as the thing I want to return. And I'll say return one of those things. Constructor. Got to be a class that has some information inside of it. Got the semicolon in the wrong place. Okay, did that right? New, I missed new. Okay. Makes me write the methods, do the same thing there. Working with the abstract class, change that to A, change that to B, and we can sort of follow the same logic that we had before. It wants the averages, so what are you going to do to get the average? Well, first of all, talk to A, get his average. So we'll get the average hours for the course. We'll do the same thing for B's average. Oops. Wrong thing. Change this one to B. And now what? Okay, so you're gonna say, let's return A average dot compared to B average. You would sort of hope that would work. Doesn't work. Why doesn't it work? So these things are native types, float, int, whatever, so the ones with keywords like that. So they don't have a compare to because they're not objects. So what did we do in the case of where it was something like an int instead of an object? Took the difference between the two. So let's give that a try. A average minus B average. You would sort of think it works, except we're working with floating point numbers here for average, and even if we take the difference of average A minus average B, we still end up with a floating point number, but we've promised to return an integer. So that won't work.